Welcome to the Fueiceel FS series. This modular PEM fuel cell platform offers standardized architecture and an innovative open-cathode design for unparalleled R&D flexibility. Our revolutionary open-cathode design eliminates expensive air compressors. A single integrated fan efficiently handles oxygen supply, heat dissipation, and water removal simultaneously. Reviewing the electrochemical mechanics, hydrogen and oxygen react across the membrane to generate clean electricity and heat, with a theoretical voltage of 1.2 to 9 volts. Here is the FS10, a 3D teardown. Its precision-engineered components, including robust endplates and graphite flow fields, ensure perfect alignment and zero hydrogen leakage. Next, we'll demonstrate the standard assembly of the Fueiceel FS10, a single-cell open-cathode fuel cell. Insert the mounting bolts through the outer holes of the left end plate, leaving an equal length exposed. Pre-install the copper current collector on the inside of the left end plate. Ensure the contact surface is clean and flat. Align the locating holes and insert the two dowel pins to prevent misalignment. Carefully place the graphite anode flow field plate onto the copper current collector. Align with the dowel pins and place the pre-assembled PTFE gasket and MEA. Align with the dowel pins and carefully place the graphite cathode flow field plate over the PTFE gasket. Pre-install the copper current collector, align the dowel pins, and attach the right cathode and plate. First, place the metal shims one by one. Next, install the nuts one by one, then finger tighten them. Tighten the bolts with a wrench in a diagonal sequence and in multiple passes to ensure even clamping force. Never fully tighten one side first to avoid damaging the graphite flow field plates and MEA. Connect the quick connect fitting to the anode side hydrogen inlet, then tighten it with a wrench. Connect the cathode side gas outlet fitting. Check all connections to ensure a leak-free seal. The Fueiceel FS10 assembly is now complete. We use high-efficiency copper current collectors and multifunctional graphite flow plates. Everything is secured by PTFE gaskets for supreme sealing and optimal compression. The platform seamlessly scales with your needs. Choose from 1 to 100 square centimeters or expand up to a 20-cell stack for higher power. Flow fields dictate performance. We offer serpentine, parallel, interdigitated, and grid designs to perfectly match your specific mass transfer and drainage research requirements. Enjoy broad GDL compatibility. The platform supports commercial carbon paper, carbon cloth, and metal fiber felts, ideal for diverse catalyst and high-temperature studies. Mastering water and temperature is crucial. Our open-cathode fin prevents flooding, while optional heating modules support high-temperature PEM tests up to 150 degrees Celsius. Setting up your ecosystem is incredibly simple. Connect standard lab peripherals to easily conduct OCV, polarization curves, and complex CIS or CV analysis. This platform empowers diverse scientific applications, from university teaching experiments and custom MEA screening, to advanced thermal management and multi-cell stack assembly training. Addressing common questions, Fixtures allow self-made MEA testing, support EIS analysis, and can be easily upgraded. SCI Materials Hub provides reliable solutions for your innovation.